Good morning to everyone. I'm Dr. Sumi MS. The topic of my today's presentation is pipelining from Unit 3 Sequential Logic Circuits and Clocking Strategies. On completion, the students will be able to obtain the data path to compute operations like log, modulus of A plus B using pipelining. Pipelining is a design technique that is used to accelerate the operation of data paths in digital processes. Consider an example where the goal of the given circuit is to compute logarithm of mod of A plus B, where A and B are both representing stream of numbers. The minimal clock period Tmin is necessary to ensure the correct evaluation, and it is given as the summation of TCQ and TPD logic and TSU, where TCQ and TSU are the propagation delay and the setup time of the register respectively. And the registers here are edge trigger deregisters. Then the term TPD logic stands for the worst case delay path through the combinational network, which consists of adder, absolute value and logarithm functions. In conventional systems, the delay is larger than the delays associated with the registers, and also this dominates the circuit performance. Assume that each logic module has an equal propagation delay, and each logic module is then active for only 1/3 of the given clock period. Hence, this can be addressed with a technique of pipelining. Pipelining is a technique to improve the resource utilization and increase the functional throughput. By introducing additional registers between these logic blocks, it can cause the computation of one set of input data to spread over a number of clock periods, and the result for the dataset A1 B1 only appears at the output after 3 clock periods. At that time, the circuit will be completing the parts of computations for the next datasets A2 B2 and A3 B3. That is, before completion of the dataset A1 B1, A2 B2 and A3 B3 execution will have been started partially. So this computation is performed in an assembly line fashion. Hence it is termed as pipelining. The combinational circuit block has been partitioned into 3 sections, each of which has a smaller propagation delay than the original function. As a result, the value of the minimum allowable clock period is getting reduced. Considering that all logic blocks have the same propagation delay and that the register overhead is small with respect to these delays, we can consider the 3 logic blocks as adder, absolute value estimation and logarithm estimation, and we are giving datasets A1, B1 for the first clock period, and while the second clock period is introduced, the A1 B1 will be in the second block and A2 B2 dataset has reached the first block, and during the third clock period A1 B1 dataset data value will be in the third block, and A2 B2 will be in the second logic block, as well as A3 B3 is in the first logic block. In this way, it is the different stages are carried out in this pipeline computation. The pipeline network performs the original circuit by a factor of 3 under the assumptions that the timing Tmin pipelining is equal to Tmin by 3. The increased performance comes at the relatively small cost of adding 2 additional registers and an increased latency. Pipelining is implemented for very high performance data paths. Quiz questions on pipelining. Obtain the computation of log mod of A plus B using pipelining. Thank you.